I want to talk about programming in general, which is chapter one of Gaddis' book. This is a very nice book written by Tony Gaddis, Judy Walters, and Godfrey Muganda. So chapter one talks about why do we need programs. It discusses hardware and software, programs and programming languages. What is the program made of? What is input? What is processing? What is output? And the programming process. So we can say that computers are programmable machines that are designed to follow instructions. We could give computers instructions, and we have a software or a program which is instructions that the computer follows to perform a task. With instructions, you can tell the computers to do something. We have someone that we call him programmer. Programmer is the person with the right skills who designs, creates, and tests program for computers. So with programs, we can make the computers to do something. We need somebody to program the computers. So that is why you guys are trying to learn programming, because you want to be able to give instructions to the computer. We can say without programmers, there are no programs. Without programs, the computer cannot do anything. If you have a computer that is not programmed, it couldn't do anything. It couldn't carry out any tasks. We say programming is an art and a science. So it's a very interesting field, programming. We can say when you create programs, you're creating an artwork. It's also a science. You organize the task that the program performs, how the information is displayed, how the user interacts with the programs. When you want to have understanding of the language that you use to write the program, when you want to understand how to test the program and change it. So programming is an art and it's also a science. Your computer has different parts. Sometimes we talk about the hardware is the physical components your computer has. These physical components, they can be like CPU, it can be your RAM, it can be secondary storage, input or output. The input for your computer can be like a mouse, it can be a keyboard, it can be a joystick, a scanner, camera. The input will help you to send something to the computer. The computer has a central processing unit, which we call it CPU. The CPU is responsible for processing the information. It means the programs, when you run them, the CPU will go there and grab the instructions one by one. It will translate those instructions to a language that your computer can understand. In order to do that, the CPU will use your RAM, the computer's RAM, which we call it random access memory. You have a secondary storage, like a hard drive, that you can store the information on it. The output can be like a display, like a monitor or TV. It can be a printer or a speaker. So in this example, you can see that we have input. With input, you send something to the computer. Your computer has a CPU, which will do the processing. It has a RAM, which is the computer's memory. The informations are stored on your hard drive, and then the result can go to the output, which can be any of these. These are the hardware of your computer. The CPU is the hardware component that runs your program. Whenever you want to run any program, the computer will use the CPU. It does have control unit and ALU. The control unit is responsible for retrieving and decoding program instructions. It will grab the instructions, it will translate them to a language that the computer can understand. It coordinates the computer operations. We have the ALU, which we call it arithmetic and logical unit. It's responsible for different logical arithmetic operations like plus, minus, multiplication, division. If you look at this picture here, we have the instruction input, which goes to the CPU as the central processing unit. The CPU has the ALU and control unit. The result will go to the output, which is the output result. So the computer will do this. Every time you run a program, the computer will use the CPU, and it will use the ALU inside the CPU to go and run your program and do any calculation that you have. We can say the role of the CPU in running a program is fetch, decode, and execute. Fetch means when the computer gets the next program instructions from the main memory, which is your RAM. Decode means to interpret the instruction and generate a signal. Execute means to route the signal to appreciate competent performance operation. It means it will grab the instruction from the memory. It will translate it to a signal. It will run the program, and that is the execution. Every time you run your program, this happens line by line, instruction by instruction. Fetch, decode, and execute. Your computer's main memory, it can hold program instructions and data. Whenever you turn off your computer, the main memory gets erased. It's temporary. So it's erased when the computer terminates the program or it's turned off. We call it random access memory, RAM, because the CPU can access data and instruction from any memory location. It means the computer will randomly access information. That is why we call it random access memory. So your computer has other memories, like you have a hard drive. If you turn off your computer, the hard drive doesn't get erased. It can keep the information. If you turn off your computer, the RAM gets erased. So the different kinds of memory. Your main memory organization, you have bit and byte. Bit is the smallest piece of memory. It can be a 0 or 1. It stands for binary digit. It holds an electronical charge. A positive charge is on, a negative charge is off. So if you put 8 consecutive bits together, you get a byte. Each byte has an address in memory, which that address indicates where that information is stored. There are millions or even billions of bytes of memory in a computer. Your computer is storing information, which those information, if you go to the smallest piece, you will see the bits. But if you put 8 of those bits together, you have a byte. So the secondary storage is a memory that you can hold the data when a program is not running, when the computer is turned off. We have different kinds of secondary storages like disk drives, or optical, or flash drives. The disk drives, they can be mounted inside the computer connected. Like you can put an external disk drive in your computer. It can store the data. You can have CD or DVD drive, which is optical. You can have flash drives, which they can store memory. So we have different forms of secondary storage. Input is used to send information to the computer from the outside. We have many devices that they can provide input. Like you can have a keyboard that you can type something and it goes to the computer. You can use a scanner. You can use a digital camera. You can have a disk drive, CD drive, or DVD drive. You can also use a USB flash drives and inputs, which it can be used to send information to the computer. Your computer can have an output device, which is used to send information from computer to outside. There are many devices that can be used for output, like computer screen, printers, speakers, disk drive, CD or DVD recorder, USB flash drive. Software programs that run a computer, we call them system software. The system softwares, they have some specific purpose. They are programs that manage the computer hardware and programs that run on the computer. An example of a system software can be like an operating system, which handles everything that happens inside your computer. It controls the operation of the computer, manages connected devices. It allows program to run. Another system software can be like utility programs that support programs that enhance computer operations. For example, you can have virus scanners, data backup, or file compression, which they are utility programs. We have also the software development tools, which we call them IDEs, like Microsoft Visual Studio or Eclipse. With IDEs, you could create programs. They are softwares that help you to create softwares. We have different kinds of system software. We can say a program is a set of instructions directing a computer to perform a task. We have different programming languages, which are special languages to write programs. In order to communicate with computer, you need to use a language, which we call the programming language. When you put some instructions together to program your computer, we call that a program. We have many different languages like C, C++, C Sharp, Java, Assembly. In this class, you guys are trying to learn C++. We say an algorithm is a set of well-defined steps to perform a task or to solve a problem. When you have an algorithm, you take some specific task, and the goal is to complete and solve a problem. Order is very important. Steps must be performed sequentially. It means what you do, it has to be in order. So if you do those steps in order, then you should be able to solve a problem. We have different types of languages. We have low-level languages and we have high-level languages. The low-level languages are used for communication and computer hardware with the hardware directly. They are not very easy for a person to read. The high-level languages are closer to human language. The languages that are near to the human language, we call them high-level languages. The ones that are not near to, like Java is a high-level language. C++ is a high-level language. Assembly is a low-level language. In low-level languages, it's not easy to write programs. If you use high-level languages, it's easy to write programs because they're near to your language. If we want to see how we can write a program in C++, we start with a file containing the program with the text editor. The program statements are called source code. We have a source file. We run the preprocessor to convert source file directives to source code program statements. What the preprocessor does, it will convert that source file directives to source code programs. The compiler will convert the source program statements into machine instructions, which we call it machine code, which is stored in an object file. So the linker will connect the hardware-specific library code to machine instructions, and it will produce an executable file. If you follow these steps, which it starts from A, by creating the code, writing the code, sending it to the preprocessor, it goes to the compiler, it goes in the linker, then if nothing goes wrong, then you can have a program that runs. Steps B to D are often performed by a single command or button click. If there is any errors that happens, then you need to fix those errors and then run your program. We start with the source code, the CPP file. It goes in the preprocessor. It gets modified. It goes in the compiler. You get the object file. It goes in the linker. You get the executable file. You can run that executable file. This is how you can create an executable file and then run it. If I want to put everything together, we have many software development systems that provide IDEs, which is Integrated Development Environment. We say an IDE has a text editor, it has a compiler, it has a debugger, it has some other supporting utilities. It has a user interface that ties everything together. With IDEs, with help of IDEs, you can create programs, which Visual Studio is one of them. There are some tools that Visual Studio has that it can help you to write programs. There are common elements in most programming languages. The language's elements are keywords, a programmer-defined identifiers, operators, punctuation, and syntax. If you look at this example, this is a very simple C++ program. We say hashtag include IOStream using namespace std. We have a main function that returns integer. It has open and close parentheses. You have a double variable num1, which we're initializing it with 5. We have num2 and sum. We say num2 equal to 12. Sum equal to num1 plus num2. See out this sum. This is a variable. This variable is type of double. Equal means I want to put 5 inside this double variable. I have another variable num2. I have a sum, which this num2 and sum, they're also double. They're decimal. We use comma to separate these. We end the statement with a semicolon. We say sum equal to num1 plus num2. I'm adding num1 and num2. I put it in the sum. I display the sum here and I have return 0. This is a very simple C++ program. The keywords, we also call them reserved words. They have a special meaning in C++ language. They cannot be used for any other purpose. They're written using lowercase letters. Some examples of the keywords can be using or namespace or int. We call them keywords because they have a specific purpose. Like int is used for numbers, like 1, 2, 20. Using namespace are keywords. It means they have to be used for this specific purpose. We have the programmer-defined identifiers, which are names made up by programmer. They're not part of the C++ language. They're used to represent various things like variables, like memory locations. For example, when you say double num1, this num1 is an identifier. It's a name for a variable. So we have some rules that you need to follow when you want to name your variables. Or if you want to name functions or classes, we need to follow some rules. We have different operators that are used to perform operations on data. We have many types of operators like arithmetic operators and assignment. Arithmetic operators can be plus, minus, multiplication, and division. Assignment is used for assigning something. In this example, when I say num2 equal to 12, 12 goes inside num2. If I say sum equal to num1 plus num2, num1 and num2 get added, and the result goes in the sum. So we have different types of operators that they do different things. If you want to do multiplication, you can use this. If you want to subtract, you can use that. If you want to add two different things, you can use plus. If you want to divide, you can use the division. Characters that mark end of a statement or that separate items in a list, we call it punctuation. For example, comma or semicolon. These are punctuation. This num2 equal to 12, we have a semicolon after that. In a source file, a line is all of the characters entered before a carriage return. Anything that you put before a carriage return, we call it a line. Blank lines improve the readability of a program. In this example here, we have a program. Line 3 is blank. Line 1 and 2, we're defining variables, which num1 is a double, num2 is a double, and sum is a double. When I say num2 equal to 12, I'm initializing num2 with 12. When you say sum equal to num1 plus num2, num2 and num1, they get added, the result goes in the sum. We say a statement is an instruction to computer to perform an action. A statement may contain keywords, operators, programmer-defined identifiers, and punctuation. In this example, when you say double num1 equal to 5, comma, num2, comma, sum, this is an statement. This is a single statement that uses two lines. So a statement may fit on one line or it may occupy multiple lines. Variables is a named location in computer memory. It holds a piece of data. The data it holds may change while the program is running. When you want to store the data in memory, you need to create variables. We call it variable because it can vary, it can change. A variable has to be defined before it can be used. If you want to define a variable, you can say, for example, double num1. This double is the data type. This num1 is the name of the variable. Variable definitions indicate the variable name and the type of data that it can hold. So in this example, this num1 can hold a double data type, which double means decimal, 2.1, 3.5, 7.8. We can say there are three steps that many programs perform. First, gathering input. Second, processing the input. Third, output the result of the processing. The input can be from a keyboard or a mouse. It can be from files on the disk drive. You process the input data. The output will be sent to the screen or a printer, or you can write it to a file. In order to create a program, so we can say the programming processes. We define what the program is going to do. We visualize the program running on the computer. We use the design tools to create a model using flowcharts, hierarchy charts, pseudocode. We check the model for logical errors. We write the program source code and we compile the source code. We correct any errors found during compilation. We link the program to create an executable file. We run the program using test data for input. If any problems, we correct them. Repeat the steps 4 to 10 as many times as necessary. We validate the result. Does the program do what was defined in step 1 or not? If we take these steps, we can create a program.